Can GPT-4 think computationally about digital archival tasks? This is an important question because an increasing number of archival records are becoming digital. Archival practices that have been used for records on paper, film, or tape now have to be re-engineered to use computers to work with digital records. At the University of Maryland, we have concluded that our archival studies grad students need to learn computational thinking skills to perform digital archival tasks. Jeanette Wing of Columbia University, in a 2006 article, described computational thinking as the way humans solve problems. She also suggested that it is a fundamental skill that all people should have, not just computer scientists. David Weintraub, one of my colleagues at the University of Maryland, has proposed a definition of computational thinking in the form of a taxonomy consisting of 22 computational thinking practices grouped into 4 main categories: data practices, modeling and simulation practices, computational problem-solving practices, and system thinking practices. This work was part of an effort to infuse computational thinking into high school science and mathematics curricular materials. Computational thinking has become a central part of the STEM curriculum. This task was to identify index cards containing personally identifiable information about minors that cannot be released to the public. The subtasks involved scanning the cards, optical character recognition, named entity recognition, developing a procedure to determine the age of individuals, coding a program, and debugging the program. These tasks involved 10 of the computational thinking activities. This process was guided by a faculty member who was a computer scientist. Many archival studies faculty do not have the background in computational thinking of a computer scientist. We have been looking for a way to provide this computational thinking ability, along with a knowledge of digital archives, to other archival studies programs and to archival practitioners. We believe we have found it in GPT-4 technology. GPT-4 is a type of artificial intelligence developed by OpenAI. It uses a deep neural network that operates with an architecture known as decoder-only transformer. GPT-4 was pre-trained on an extremely large corpus of text, including millions of web pages, tens of thousands of books, and all of Wikipedia. This means that it is capable of generating responses on a wide variety of topics, including digital archives. Given a prompt from a user and possibly additional content for the prompt, GPT-4 predicts the response to the prompt. GPT-4 has demonstrated a high level of performance, achieving a score of 1410 on the Scholastic Aptitude Test, placing it in the 94th percentile. GPT-4 sometimes generates responses that are incorrect or misleading. This is an important issue for archivists who may rely on the responses for critical tasks. One can register with OpenAI to use GPT-4 online. GPT-4 Mini is free, while GPT-4 and GPT-4o are available for $20 per month. When you select the ChatGPT button, the drop-down menu shown on this slide appears. Data analysis includes statistical analysis, machine learning, and natural language processing. DALL-E 3 can create images from text prompts. For instance, when prompted, give me a realistic picture of what you would look like if you, GPT-4, were a real person. It generated several possibilities, two of which are shown here. Here is a conversation with GPT-4, also known as ChatGPT+, about creating data. Joe is the nickname GPT-4 assigned to my co-author, Joan Gage. You can prompt GPT-4 in various ways, including asking it a question or asking it to do something. Joe asked it to list the 3 best OCR programs for Windows 10. It listed Adobe Acrobat Pro, Abby Fine Reader, and Python Tesseract, as well as their advantages and disadvantages. You can also upload background information or a digital object for consideration by GPT-4. Joe selected the Advanced Data Analysis plugin. She also uploaded a digital image of a card used in the PII task. She then asked GPT-4 to OCR the digital image. It did so using Python Tesseract. It even mentioned that it might have made an error. GPT-4 not only knows how to OCR images of text, but is able to do so. It is not shown in this presentation, but Joe asked GPT-4 about methods for modeling systems. GPT-4 identified 10 methods, one of which was IDEF0. In this slide is shown a conversation in which Joe asked GPT-4, using IDEF0, what would be the inputs, outputs, controls, and mechanisms of the context diagram of the function archive digital records? GPT-4 responded with reasonable inputs, outputs, and on the next slide, the controls and mechanisms. It then described how to draw the context diagram. GPT-4 represents a significant advancement in AI technology with benefits for archival science. While I have only shown you conversations with GPT-4 about 2 archival tasks and 2 corresponding computational thinking practices, we have shown that GPT-4 knows how to perform digital archival tasks corresponding to all 22 computational thinking practices. By using GPT-4 technology, archivists can enhance their ability to think computationally and perform digital archival tasks. Here are some sources of more detailed information. Cited below is the article, Can GPT-4 Think Computationally About Digital Archival Practices? This was presented at the CAS workshop in 2023. It discusses conversations with GPT-4 that covered 10 of the computational thinking practices. The second article, GPT-4 Can Think Computationally About Digital Archival Tasks. This article will be submitted to the CAS workshop in Washington, D.C. this December. This article discusses conversations with GPT-4 that cover the remaining 12 computational thinking practices. Also listed here is the URL to the website that hosts ChatGPT.